The ancient world holds secrets that challenge everything we think we know about human capability and ingenuity. Scattered across the globe are monuments, structures, and artifacts that seem to defy the technological limitations of their time. These incredible feats of engineering continue to puzzle archaeologists, historians, and scientists who struggle to explain how ancient civilizations accomplished what appears impossible with the tools and knowledge they supposedly possessed. Today we're diving deep into 7 of the most mind-bending examples of ancient engineering that were seemingly beyond their time. From precision stonework that rivals modern laser cutting to acoustic phenomena that suggest advanced understanding of physics, these achievements force us to reconsider what our ancestors were truly capable of. Some of these discoveries have only recently been properly analysed using cutting-edge technology, revealing layers of sophistication that were previously invisible to researchers. What makes these engineering marvels so extraordinary is not just their scale or beauty, but the precision and knowledge required to create them. We're talking about structures built thousands of years ago that demonstrate understanding of mathematics, astronomy, acoustics, and materials science that we assumed didn't exist until much later in human history. The tools required to achieve such precision, according to conventional archaeology, simply weren't available to these ancient builders. Let's begin our journey in the heart of Egypt, where the Great Pyramid of Giza stands as perhaps the most famous example of impossible ancient engineering. This colossal structure, built around 4,500 years ago, contains roughly 2.3 million stone blocks, each weighing between 2.5 and 15 tons. The precision with which these blocks were cut and fitted together is absolutely staggering. The gaps between the stones are so narrow that you can't slide a piece of paper between them. The base of the Great Pyramid is level to within just 2.1 centimeters. To put this in perspective, that's more accurate than most modern construction projects achieve today. The 4 sides of the pyramid align almost perfectly with the cardinal directions, with an error of only 3 minutes and 6 seconds of arc. This level of precision would be challenging even with modern surveying equipment and GPS technology. But the precision doesn't stop there. The pyramid's dimensions encode mathematical relationships that weren't supposed to be known for thousands of years. The ratio of the pyramid's perimeter to its height equals pi, accurate to several decimal places. The structure also incorporates the golden ratio, a mathematical constant that appears throughout nature and was thought to be discovered much later by Greek mathematicians. The construction techniques required to build such a monument remain largely mysterious. Moving blocks weighing up to 15 tons with the supposed technology available 4,500 years ago should have been virtually impossible. Yet somehow these ancient engineers not only moved these massive stones, but positioned them with millimeter precision. The internal chambers of the pyramid feature granite blocks weighing up to 80 tons, transported from quarries hundreds of miles away and somehow maneuvered into position deep within the structure. Moving from Egypt to Peru, we encounter another engineering marvel that defies conventional explanation. High in the Andes Mountains, at an altitude of over 12,000 feet, lies the ancient site of Sacsayhuaman. This fortress-like complex features massive stone walls built from precisely cut blocks that fit together like puzzle pieces. Some of these blocks weigh over 200 tons, making them among the heaviest stones ever used in construction. What sets Sacsayhuaman apart is not just the size of the stones but the complexity of their shapes. These aren't simple rectangular blocks. Many have dozens of angles and irregular surfaces that interlock perfectly with their neighbours. The precision is so exact that the joints between stones remain earthquake-proof after centuries of seismic activity in this geologically active region. The cutting techniques used to shape these stones remain a complete mystery. The hardest stone used at the site is andesite, which ranks about 6 to 7 on the Mohs hardness scale. Working with such hard stone would require tools made of materials even harder, yet no evidence of such tools has been found. The surfaces of the stones show no chisel marks or other signs of conventional stoneworking techniques. Local legends speak of the stones being softened like clay before being shaped and fitted together. While this sounds fantastical, some researchers have speculated about possible chemical processes or unknown technologies that could have achieved such results. The precision achieved in shaping these irregular blocks would be challenging, even with modern diamond-tipped tools and computer-controlled cutting equipment. Another aspect of Sacsayhuaman that puzzles engineers is how the massive stones were transported and lifted into position. The quarries where the stones originated are located several miles away, across rugged mountain terrain. Moving a 200-ton block over such terrain without modern machinery seems impossible, yet it was clearly accomplished. Some of the largest stones are positioned high up in the walls, requiring them to be lifted dozens of feet into the air. Travelling to Lebanon, we find yet another example of seemingly impossible ancient engineering at the temple complex of Baalbek. Here, 3 enormous stone blocks known as the trilithon form part of the temple's foundation. Each of these blocks weighs approximately 800 tons, making them among the heaviest stones ever used in construction anywhere in the world. The precision with which these massive blocks were cut and fitted is remarkable. Despite their enormous weight, they fit together so perfectly that the joints are nearly invisible. The blocks were quarried about half a mile away, and somehow transported to the construction site, then lifted and positioned with extraordinary accuracy. Even today, moving and positioning stones of this size would require the largest cranes in the world. What makes the trilithon even more mysterious is that these massive blocks aren't even at ground level. They're positioned high up in the temple's retaining wall, requiring them to be lifted to a considerable height. The logistics of accomplishing such a feat with ancient technology seem impossible. Modern construction cranes capable of lifting 800-ton loads are enormous machines that require extensive preparation and infrastructure to operate. Near the Baalbek quarry lies an even larger stone block that was never moved. This block, sometimes called the Stone of the Pregnant Woman, weighs an estimated 1,000 tons. It appears to have been cut and prepared for transport, but was left behind for unknown reasons. The existence of this block proves that the ancient builders had developed techniques for working with stones of truly massive proportions. The precision of the cutting at Baalbek extends beyond just the famous trilithon blocks. Throughout the complex, stones are fitted together with incredible accuracy. Many joints are so tight that they appear to have been welded rather than simply placed together. The level of craftsmanship displayed throughout the site suggests a mastery of stone working techniques that far exceeded what we believe was possible for the time period. From the Mediterranean, we journey to Easter Island in the Pacific Ocean, where nearly 1,000 monolithic statues called moai stand as silent witnesses to another remarkable feat of ancient engineering. These statues, carved from volcanic rock, were created by the Rapa Nui people between 1250 and 1500 CE. What makes them extraordinary isn't just their number or size, but the precision and sophistication of their creation and placement. The moai were carved at quarry sites using only stone tools, yet they display a level of artistic and technical skill that rivals modern sculpture. Each statue required removing tons of rock with incredible precision to achieve the final form. The largest completed moai stands 33 feet tall and weighs approximately 82 tons. The unfinished statues at the quarry sites suggest that even larger moai were planned, with some reaching heights that would have exceeded 70 feet if completed. The transportation of these massive statues across the island presents another engineering puzzle. Nearly 400 moai were moved from the quarry sites to various locations around the island, some travelling distances of up to 11 miles. Recent experiments have suggested that the statues may have been walked upright using a coordinated rocking motion, but this technique would still require remarkable engineering knowledge to execute successfully with such massive objects. The precision with which the moai were positioned is also noteworthy. Many of the statues are arranged in precise alignments that correspond to astronomical phenomena. The orientation of the statues appears to have been carefully calculated to mark important celestial events, suggesting sophisticated knowledge of astronomy and surveying techniques. Perhaps most intriguing is the discovery that many of the moai have bodies buried beneath the soil, making them much larger than previously thought. These buried portions display the same level of craftsmanship as the visible heads, with intricate carvings and petroglyphs that were hidden for centuries. The full scope of the moai project is only now being understood as excavations reveal the true scale of these monuments. The construction techniques used to create the moai reveal an understanding of engineering principles that seems remarkably advanced for the time period. The statues were carved using a systematic approach that maximized efficiency while maintaining incredible artistic quality. The quarry sites show evidence of organized production lines, with different stages of carving taking place in designated areas. This level of industrial organization suggests sophisticated project management capabilities that rival modern construction operations. Moving across the Pacific to Cambodia, we encounter Angkor Wat, a temple complex that represents one of the most ambitious construction projects in human history. Built in the early 12th century, This massive structure covers an area of over 400 acres and required the precise placement of millions of sandstone blocks. What makes Angkor Wat truly extraordinary is not just its size, but the incredible precision of its construction and the advanced engineering solutions employed throughout the complex. The temple's foundation demonstrates remarkable engineering foresight. Built in an area prone to flooding, the entire complex sits on an elaborate system of canals, reservoirs, and drainage channels that manage water flow with incredible efficiency. This hydraulic engineering system spans hundreds of square miles and includes sophisticated mechanisms for water storage, distribution, and flood control. The precision of the water management system rivals modern hydraulic engineering projects. The stone blocks used in Angkor Wat's construction fit together with extraordinary accuracy despite their massive size. Some blocks weigh several tons, yet they're positioned so precisely that the joints between them are nearly invisible. The cutting and shaping of these stones required techniques that produce surfaces flat to within millimeters across spans of several feet. This level of precision would be challenging to achieve even with modern diamond-cutting tools. The temple's architectural design incorporates advanced mathematical principles that weren't supposed to be known in the 12th century. The proportions of the structure follow complex geometric relationships that create optical illusions, making the temple appear perfectly proportioned from multiple viewing angles. The builders demonstrated sophisticated understanding of perspective, optics, and human visual perception in designing these architectural effects. Perhaps most impressive is the acoustic engineering embedded throughout Angkor Wat. Specific locations within the temple produce remarkable sound effects when visitors clap or speak. These acoustic phenomena aren't accidental, but appear to be deliberately engineered into the structure's design. The builders somehow calculated the precise dimensions and materials needed to create these acoustic effects, suggesting advanced knowledge of sound physics and architectural acoustics. Our journey takes us next to Turkey, where the underground city of Derinkuyu represents an entirely different type of impossible engineering feat. Carved directly into solid rock, this subterranean complex extends at least 18 levels deep into the earth, with some estimates suggesting it could go even deeper. The city could accommodate up to 20,000 people, along with their livestock and food supplies, making it one of the largest underground settlements ever discovered. The precision required to excavate such a complex while maintaining structural integrity is staggering. The builders had to calculate load-bearing requirements, ensure proper ventilation throughout multiple levels, and create a network of tunnels and chambers that wouldn't collapse under the immense weight of the rock above. Modern tunnel engineering requires extensive computer modelling and sophisticated understanding of geology, yet these ancient builders achieved similar results using unknown methods. The ventilation system at Derinkuyu is particularly remarkable. Fresh air is distributed throughout all 18 levels through a network of precisely calculated shafts and channels. The system maintains breathable air quality even at the deepest levels, suggesting advanced understanding of airflow dynamics and atmospheric pressure. The engineering required to design such a system without modern computational tools seems nearly impossible. The excavation techniques used to create Derinkuyu remain mysterious. Removing millions of tons of solid rock with the tools supposedly available to ancient builders should have taken centuries, yet evidence suggests the city was completed in a relatively short time period. The precision of the excavation is evident in the smooth walls and carefully shaped chambers throughout the complex. Many rooms feature perfectly circular openings and geometrically precise architectural details that would challenge modern stone carving techniques. Water management within the underground city demonstrates another level of engineering sophistication. A complex system of wells, drainage channels, and water storage areas ensures adequate water supply throughout the multi-level complex. The builders had to account for water pressure, flow rates, and contamination prevention while working entirely underground. The precision of this hydraulic engineering rivals modern water distribution systems. Our exploration concludes with perhaps the most enigmatic example of ancient precision engineering, the massive stone spheres of Costa Rica. Scattered throughout the Diqui Delta region are over 300 perfectly spherical stone balls ranging in size from a few inches to over 8 feet in diameter. The largest of these spheres weighs approximately 15 tons, yet maintains perfect spherical geometry with deviations of less than a few millimeters. Creating a perfect sphere from solid stone is an extraordinarily difficult task even with modern machine tools. The process requires removing material with incredible precision while maintaining perfect symmetry in 3 dimensions. Any error in calculation or execution would result in visible imperfections, yet many of these ancient spheres are geometrically perfect within the limits of measurement accuracy available to researchers. The stone used to create these spheres is primarily granodiorite, an extremely hard volcanic rock that ranks high on the Mohs hardness scale. Working such hard material to achieve perfect spherical geometry would require tools and techniques far beyond what conventional archaeology suggests was available to the ancient inhabitants of Costa Rica. The surface finish on many spheres is so smooth it appears polished, adding another layer of complexity to their creation. The transportation and placement of these massive spheres presents additional engineering challenges. Many are located in areas that would have required moving them across difficult terrain, including rivers and dense jungle. The precision with which some spheres are arranged suggests they weren't randomly placed but positioned according to specific plans that may have incorporated astronomical or mathematical principles. Recent analysis using advanced 3D scanning technology has revealed that the most perfectly spherical examples maintain their geometry to within tolerances that would challenge modern manufacturing. The consistency of this precision across spheres of different sizes suggests the ancient craftsmen had developed standardized techniques and possibly even measuring tools that could ensure repeatable results. The purpose of these stone spheres remains completely unknown, adding to their mystery. Unlike other ancient monuments that clearly served religious, defensive, or residential purposes, the spheres appear to have no obvious practical function. Their creation required enormous investments of time, skill, and resources, yet their intended use remains hidden from modern understanding. This suggests they may have served purposes related to knowledge or technologies that we don't yet comprehend. The geological analysis of the spheres has revealed another puzzling aspect of their creation. The stone used in their construction often came from quarries located many miles away from where the finished spheres were discovered. This means the ancient engineers either transported raw stone blocks over considerable distances before carving them into spheres, or somehow moved the finished spheres across challenging terrain without damaging their perfect geometry. Perfect geometry. The manufacturing precision evident in these Costa Rican spheres extends beyond their geometric perfection. Chemical analysis has revealed that many spheres display uniform composition throughout their structure, suggesting the ancient craftsmen possessed sophisticated understanding of material properties and quality control. This consistency indicates they could identify and select stone with the exact characteristics needed for their mysterious purposes. What makes the spheres even more perplexing is evidence suggesting they were created over an extended period spanning several centuries, yet they maintain remarkably consistent quality standards. This implies the techniques for creating them were preserved and transmitted across generations with extraordinary accuracy. The knowledge required to achieve such consistency would have needed to be recorded and taught systematically, suggesting levels of technical documentation and education that challenge our assumptions about ancient societies. The arrangement of multiple spheres at certain sites displays patterns that appear deliberate rather than random. Some groupings form geometric configurations that may correspond to celestial phenomena or mathematical relationships. The precision required to survey and position these massive objects according to predetermined patterns would have demanded advanced knowledge of geometry and possibly astronomy. The logistics alone of coordinating such precise placement across multiple sites indicates sophisticated project management capabilities. Recent discoveries have uncovered additional spheres buried beneath centuries of sediment, expanding our understanding of their original distribution and arrangement. These newly revealed examples often show the same perfect craftsmanship as their previously known counterparts, confirming that the quality standards were maintained throughout the entire production period. Ground-penetrating radar surveys suggest even more spheres remain hidden, potentially revealing larger patterns or arrangements that could provide clues about their intended purpose. Moving from Costa Rica to the ancient world of Mesopotamia, we encounter another engineering marvel that challenges conventional understanding of ancient capabilities. The Antikythera mechanism, discovered in a shipwreck off the Greek island of Antikythera, represents a level of mechanical sophistication that wasn't supposed to exist for another 1,000 years. This bronze device, dating to around 100 BCE, is essentially an ancient analog computer designed to predict astronomical positions and eclipses decades in advance. The mechanism contains over 80 bronze gears arranged in a complex system that performs calculations equivalent to modern mathematical operations. The precision required to manufacture these gears using ancient techniques seems impossible. The teeth on each gear had to be cut with incredible accuracy to ensure smooth operation and prevent the accumulated errors that would render the device useless. Modern attempts to recreate the mechanism using period-appropriate tools have proven extremely challenging. The mathematical knowledge embedded in the Antikythera mechanism demonstrates understanding of astronomical cycles and planetary motions that rivals modern calculations. The device accurately models the elliptical orbit of the Moon, incorporating irregularities in lunar motion that weren't supposed to be known until the work of Johannes Kepler in the 17th century. The gear ratios used in the mechanism encode precise mathematical relationships that reflect sophisticated understanding of celestial mechanics. The manufacturing techniques required to create such intricate mechanical components remain largely mysterious. The bronze gears show evidence of being shaped using methods that produced incredibly smooth and precise surfaces. Some components are so small and detailed that they would challenge modern precision manufacturing. The assembly process would have required extraordinary skill and knowledge of mechanical principles that seem far advanced for the supposed technological level of ancient Greece. X-ray tomography and advanced imaging techniques have revealed additional complexity within the mechanism that wasn't visible from external examination. Hidden gear trains and mechanical linkages demonstrate that the device was even more sophisticated than initially realized. The internal architecture shows evidence of modular design principles and standardized components that suggest systematic engineering approaches typically associated with much later periods in technological development. The Antikythera mechanism represents just one example of ancient mechanical engineering that defies chronological expectations. Similar levels of precision and sophistication appear in other artifacts from the ancient world, suggesting that advanced mechanical knowledge was more widespread than previously believed. The existence of such devices forces us to reconsider our assumptions about the technological capabilities of ancient civilizations. Our exploration of impossible ancient engineering continues with the megalithic temples of Malta, where precision stonework reaches levels that challenge modern capabilities. These temple complexes, built between 3600 and 2500 BCE, feature massive limestone blocks cut and fitted with extraordinary accuracy. Some blocks weigh over 50 tons, yet they're positioned with millimeter precision to create complex architectural forms that have stood for over 5,000 years. The cutting techniques used on the Maltese temples produce surfaces so smooth and precise that they appear machined rather than hand-carved. Tool marks are virtually absent from many surfaces, suggesting finishing techniques that went far beyond simple stone carving methods. The precision extends to decorative elements carved into the stone, including intricate spiral patterns and geometric designs that required extremely controlled cutting techniques. The temples demonstrate sophisticated understanding of structural engineering principles that weren't supposed to be known for millennia. The builders used advanced techniques for distributing loads and managing structural stresses that allowed them to create large interior spaces without internal supports. The engineering solutions employed in these temples rival modern approaches to stone construction, yet they were implemented using supposedly primitive tools and methods. Acoustic analysis of the Maltese temples has revealed another layer of engineering sophistication. Specific chambers within the temples produce remarkable resonance effects at particular frequencies. These acoustic properties appear to be deliberately engineered into the structures, suggesting the builders possessed advanced knowledge of sound physics and architectural acoustics. The precision required to achieve these acoustic effects would have demanded sophisticated understanding of wave mechanics and resonance phenomena. The quarrying and transportation of the massive stone blocks used in the temples presents additional engineering puzzles. The limestone was extracted from quarries using techniques that produced blocks with incredibly flat and smooth surfaces. Moving these massive stones across the island and positioning them with millimeter accuracy would have required engineering solutions that seem impossible, given the tools supposedly available to the temple builders. Recent archaeological investigations have uncovered evidence of even older structures beneath the known temples, suggesting that advanced stoneworking techniques were being used in Malta for much longer than previously realized. These earlier structures display the same precision and sophistication as the later temples, indicating that the engineering knowledge required for their construction was well established and consistently applied over extended periods. The precision evident in these ancient engineering marvels extends far beyond what we've examined so far. In Peru, the ancient site of Ollantaytambo features stone walls with joints so precise that researchers have measured gaps of less than 1/16th of an inch between blocks weighing several tons. The cutting techniques used to achieve such precision remain completely unknown, as no tool marks or evidence of conventional stoneworking methods can be found on the surfaces. The blocks at Ollantaytambo display another puzzling characteristic. Many appear to have been shaped while hot or in a plastic state, with edges that seem to have flowed together rather than being cut and fitted. This observation has led some researchers to speculate about unknown technologies or chemical processes that could have softened stone during the construction process. The implications of such techniques would revolutionize our understanding of ancient technological capabilities. Similar precision appears at sites throughout the ancient world, from the perfectly fitted stones of Japanese castle foundations to the incredibly accurate megalithic structures of ancient Armenia. The consistency of this precision across different cultures and time periods suggests that advanced stoneworking techniques were more widespread in the ancient world than conventional archaeology acknowledges. The tools required to achieve such precision in stoneworking would need to be harder than the stones being cut, yet no evidence of such tools has been found at most of these sites. Diamond-tipped tools would be required to work some of the harder stones with the precision evident in these ancient structures, yet diamonds weren't supposed to be used for cutting tools until much later in human history. The absence of appropriate tools creates a fundamental paradox in explaining how these engineering feats were accomplished. Modern experiments attempting to recreate ancient stoneworking techniques using period-appropriate tools have consistently failed to achieve the levels of precision evident in these ancient structures. Even using modern diamond-tipped tools and computer-controlled cutting equipment, replicating some of the geometric precision found in ancient stonework remains extremely challenging. This raises profound questions about the methods and technologies available to ancient builders. The engineering precision we observe in these ancient monuments becomes even more remarkable when we consider the mathematical knowledge required for their creation. At the ancient site of Newgrange in Ireland, built around 3200 BCE, the entire structure demonstrates sophisticated understanding of solar astronomy and geometric principles that weren't supposed to be discovered for thousands of years. The passage tomb is aligned so precisely that sunlight enters the chamber only during the winter solstice, illuminating the interior for exactly 17 minutes. What makes Newgrange extraordinary isn't just this astronomical alignment, but the engineering precision required to achieve it. The builders had to calculate the exact angle and orientation of the entrance passage to capture sunlight at the precise moment when the sun reaches its lowest point in the sky. This required advanced knowledge of the Earth's axial tilt, the mechanics of solar motion, and complex trigonometric calculations that supposedly weren't developed until much later periods. The construction of the light box above the entrance demonstrates mechanical engineering sophistication that rivals modern precision instruments. The opening is calculated to allow sunlight to travel down the 19-meter passage and strike the back wall of the chamber with incredible accuracy. The slightest miscalculation in angle or positioning would have rendered the entire astronomical function useless, yet the system has operated flawlessly for over 5,000 years. The corbelled roof of Newgrange represents another engineering marvel that challenges our understanding of ancient structural capabilities. The roof consists of overlapping stone slabs that create a self-supporting dome without any internal framework or mortar. Each stone had to be precisely shaped and positioned to distribute the enormous weight evenly while maintaining structural integrity. Modern structural engineers struggle to replicate this technique using contemporary methods and materials. The waterproofing system integrated into Newgrange's design demonstrates advanced understanding of moisture control and building physics. Despite being constructed entirely of stone without modern sealants, the interior chamber has remained completely dry for over 5 millennia. The builders incorporated sophisticated drainage systems and vapor barriers that prevent water infiltration while allowing the structure to breathe naturally. This level of building science wasn't supposed to be understood until the development of modern construction techniques. Moving to the ancient Americas, we encounter the mysterious site of Tiwanaku near Lake Titicaca in Bolivia. This complex features stone blocks that have been shaped with such precision that they interlock in 3 dimensions like pieces of an incredibly complex puzzle. Some blocks have over a dozen precisely cut surfaces that mate perfectly with their neighbours, creating joints so tight that they've remained earthquake-proof for over 1,000 years. The Akapana Pyramid at Tiwanaku demonstrates hydraulic engineering that seems impossible for its time period. The structure contains an elaborate internal drainage system with precisely calculated channels, flow rates, and pressure differentials that manage water movement throughout the multi-level complex. The engineering required to design such a system would challenge modern hydraulic engineers, yet it was somehow accomplished using supposedly primitive tools and knowledge. The stone cutting at Tiwanaku reaches levels of precision that seem to require machine tools. Many blocks display surfaces that are flat to within fractions of millimeters, across spans of several feet. The corners and edges are so sharp and precise that they appear to have been cut with modern machinery rather than ancient hand tools. Some surfaces show a mirror-like polish that would be difficult to achieve even with contemporary diamond polishing equipment. Laboratory analysis of stone samples from Tiwanaku has revealed another puzzling aspect of the construction. The chemical composition of some blocks suggests they may have been subjected to extreme temperatures during the shaping process, yet there's no evidence of the massive furnaces or heating systems that would have been required to achieve such temperatures. This has led some researchers to speculate about unknown thermal processing techniques that could have been used to soften stone during construction. The precision extends to decorative elements throughout Tiwanaku, including intricate carvings that display mathematical relationships and astronomical alignments. Many of these carvings incorporate complex geometric patterns that encode sophisticated mathematical concepts, including fractals, logarithmic spirals, and other advanced mathematical principles that weren't supposed to be known in the ancient Americas. Our investigation of impossible ancient engineering leads us to the Great Wall of China, where the scale and precision of construction defies comprehension even today. While most people focus on the wall's impressive length, the engineering sophistication required for its construction is equally remarkable. The wall incorporates advanced surveying techniques that maintain consistent elevation and grade across thousands of miles of extremely challenging terrain. The foundation systems used throughout the Great Wall demonstrate engineering knowledge that rivals modern approaches to construction in difficult terrain. The builders developed techniques for creating stable foundations on steep slopes, loose soil, and rocky terrain that have proven more durable than many modern construction methods. The wall has survived earthquakes, floods, and extreme weather conditions for over 2,000 years without major structural failures. The materials engineering evident in the Great Wall's construction shows sophisticated understanding of composite materials and chemical processes. The mortar used in many sections contains ingredients that create chemical bonds stronger than the stones themselves. Analysis of this mortar has revealed complex formulations that include organic additives and mineral compounds that enhance strength and durability beyond what should have been possible with ancient chemistry knowledge. The logistics of constructing the Great Wall represent perhaps the most impressive aspect of the entire project. Coordinating the movement of millions of tons of materials across thousands of miles of remote terrain required organizational capabilities that rival modern large-scale construction projects. The builders developed supply chain management systems, quality control procedures, and project coordination techniques that enabled them to maintain consistent construction standards across the entire length of the wall. Recent archaeological discoveries have revealed that the Great Wall incorporates sophisticated communication systems that allowed rapid transmission of information across vast distances. These systems include precisely positioned beacon towers with calculated sight lines that could relay complex messages using fire and smoke signals. The engineering required to design such a communication network would have demanded advanced knowledge of optics, atmospheric conditions, and signal processing techniques. The precision evident in these ancient engineering achievements extends to astronomical observatories that demonstrate remarkable understanding of celestial mechanics and mathematical principles. The ancient observatory at Chanquillo in Peru consists of 13 precisely positioned stone towers that create a solar calendar accurate to within days over the course of a full year. The positioning of these towers required calculations that account for the Earth's orbital mechanics and the complex motion of the Sun throughout the year. The engineering precision at Chanquillo extends beyond simple astronomical observation to include sophisticated understanding of human perception and optical illusions. The towers are positioned and sized to create specific visual effects when viewed from designated observation points, demonstrating advanced knowledge of perspective geometry and visual psychology. The builders somehow calculated the exact dimensions and positions needed to create these optical effects using mathematical principles that weren't supposed to be known for centuries. Similar astronomical engineering appears at sites throughout the ancient world, from the stone circles of Britain to the pyramid complexes of Mesoamerica. These structures demonstrate consistent levels of precision and sophistication that suggest widespread knowledge of advanced engineering principles that conventional archaeology cannot adequately explain. The mathematical accuracy required for these astronomical alignments would have demanded tools and techniques that seem impossible given our current understanding of ancient technological capabilities. The metallurgy evident in ancient artifacts presents another dimension of impossible engineering that challenges conventional chronologies of technological development. The Damascus steel produced in ancient Syria displayed properties that modern metallurgy has struggled to replicate despite centuries of scientific advancement. These blades contained carbon nanotube structures that weren't supposed to be possible without advanced materials science knowledge and sophisticated manufacturing techniques. Analysis of ancient bronze artifacts has revealed alloy compositions and manufacturing techniques that demonstrate remarkable understanding of materials science. Some ancient bronzes contain trace elements and additives that enhance their properties in ways that suggest systematic experimentation and quality control processes. The consistency of these advanced alloys across different cultures and time periods indicates that sophisticated metallurgical knowledge was more widespread in the ancient world than previously believed. The precision evident in ancient metalworking extends to jewellery and decorative objects that display craftsmanship rivaling modern techniques. Ancient goldsmiths created chains with links so small and precisely formed that they appear to have been made using modern precision machinery. The tools and techniques required to achieve such precision in metalworking remain largely unknown, as no evidence of appropriate manufacturing equipment has been discovered at most ancient sites. These examples of impossible ancient engineering continue to challenge our understanding of human technological development and force us to reconsider fundamental assumptions about the capabilities of ancient civilizations. The precision, sophistication, and scale of these achievements suggest that our ancestors possessed knowledge and techniques that have been lost to history, leaving behind monuments and artifacts that seem to defy the technological limitations of their time. The precision manufacturing evident in ancient metalworking becomes even more perplexing when we examine microscopic details that have only recently been revealed through advanced analysis techniques. Ancient craftsmen somehow achieved surface finishes on metal objects that approach modern machining tolerances, with roughness measurements that would be challenging to replicate using contemporary precision equipment. The consistency of these surface qualities across different metal types and artifact categories suggests systematic manufacturing processes that contradict our understanding of ancient production capabilities. Archaeological investigations have uncovered ancient workshops containing evidence of mass production techniques that seem centuries ahead of their time. These sites reveal standardized component manufacturing, quality control systems, and assembly line processes that mirror modern industrial organization. The precision tooling marks found on artifacts from these workshops display characteristics that typically result from machine-based manufacturing rather than handcrafting, yet no evidence of such machinery has been discovered. The chemical analysis of ancient pigments and dyes reveals another dimension of impossible engineering sophistication. Ancient civilizations somehow developed color formulations that maintain their vibrancy after thousands of years, outperforming many modern synthetic alternatives in terms of longevity and color stability. The molecular structures of these ancient pigments often incorporate nanotechnology-level engineering that shouldn't have been possible without advanced chemistry knowledge and precision manufacturing techniques. Recent spectroscopic analysis of ancient glass artifacts has revealed manufacturing techniques that seem to require temperature control and atmospheric manipulation beyond the capabilities of ancient furnaces. Some glass objects display internal stress patterns and optical properties that suggest controlled cooling processes and precise atmospheric composition during manufacturing. The consistency of these advanced properties across different archaeological sites indicates widespread knowledge of sophisticated glass-making techniques that challenge conventional timelines of technological development. The engineering precision extends to ancient textile production, where recently discovered fabrics display weaving techniques and thread consistency that approach modern machine-made standards. Some ancient textiles contain fiber counts and weave patterns so precise and uniform that they appear to have been produced using mechanized looms rather than hand-operated equipment. The mathematical precision evident in the pattern calculations and thread spacing suggests advanced understanding of textile engineering principles that weren't supposed to exist for centuries. Archaeological evidence from ancient mining operations reveals extraction techniques and ore processing methods that demonstrate remarkable understanding of geological engineering and materials science. Ancient miners somehow developed methods for following ore veins through complex geological formations with precision that rivals modern mining techniques. The efficiency and selectivity of these ancient extraction methods often exceeded what should have been possible, given the tools and knowledge supposedly available to ancient civilizations. The ventilation systems discovered in ancient mines display engineering sophistication that challenges our understanding of ancient capabilities in atmospheric engineering and fluid dynamics. These systems maintained breathable air quality at depths and distances that should have been impossible without modern ventilation technology. The calculations required to design such systems would have demanded advanced understanding of air pressure, flow rates, and atmospheric chemistry that seems far beyond ancient knowledge. Underground water management systems from the ancient world reveal hydraulic engineering that rivals modern municipal water distribution networks. These systems maintained consistent water pressure and flow rates across vast underground networks while preventing contamination and managing waste disposal. The precision required to survey and construct such systems through solid rock formations would challenge contemporary engineering capabilities, yet they were somehow accomplished using supposedly primitive tools and techniques. The acoustic engineering embedded in ancient structures continues to reveal new layers of sophistication as modern analysis techniques improve. Some ancient chambers produce sound effects so precise and controlled that they appear to have been designed as acoustic instruments rather than simple architectural spaces. The mathematical calculations required to achieve such acoustic precision would have demanded advanced understanding of wave mechanics, resonance phenomena, and architectural acoustics that wasn't supposed to exist in the ancient world. Recent discoveries of ancient optical devices have revealed understanding of lens manufacturing and optical engineering that predates known developments in optics by centuries. These devices display surface qualities and geometric precision that approach modern optical standards, suggesting manufacturing techniques that could produce controlled focal lengths and minimal optical distortion. The knowledge required to design and manufacture such devices would have included advanced understanding of light physics and precision grinding techniques. The preservation techniques used by ancient civilizations demonstrate chemical engineering knowledge that sometimes surpasses modern methods. Ancient embalmers and food preservation specialists developed chemical formulations that maintained organic materials for thousands of years with minimal degradation. The molecular analysis of these preservation systems reveals complex chemical interactions and controlled reactions that suggest systematic understanding of biochemistry and material science. Ancient construction adhesives and mortars often display properties that exceed modern construction materials in terms of durability and environmental resistance. Some ancient formulations have maintained their structural integrity for millennia, while exposed to extreme weather conditions that would destroy contemporary construction materials within decades. The chemistry required to develop such formulations would have demanded understanding of molecular bonding, chemical reactions, and material science that seems impossible for ancient civilizations. The precision evident in ancient surveying and mapping projects reveals mathematical and engineering capabilities that challenge conventional understanding of ancient knowledge. Some ancient maps display accuracy levels that shouldn't have been achievable without modern surveying equipment and mathematical techniques. The calculations required for such precision would have included advanced trigonometry, spherical geometry, and astronomical observations that weren't supposed to be known for centuries. Archaeological evidence suggests that ancient civilizations possessed understanding of materials science that enabled them to manipulate matter at levels approaching modern nanotechnology. Some ancient artifacts display engineered properties at molecular scales that require precise control over material composition and structure. The techniques needed to achieve such material manipulation would have demanded scientific knowledge and manufacturing capabilities that seem impossible given conventional timelines of technological development. The consistency of engineering precision across different ancient civilizations and time periods suggests that advanced technical knowledge was more widespread in the ancient world than previously recognized. The mathematical accuracy, manufacturing precision, and engineering sophistication evident in these achievements indicate systematic development and application of scientific principles that challenge fundamental assumptions about human technological progress. These remarkable engineering achievements continue to expand our understanding of ancient capabilities, while raising profound questions about lost knowledge and forgotten technologies. The precision and sophistication evident in these ancient works suggest that human technological development may not have followed the linear progression that conventional archaeology assumes, but instead involved periods of advanced knowledge that were subsequently lost to history. The implications of these discoveries extend far beyond simple historical curiosity, challenging us to reconsider fundamental assumptions about human capability and the nature of technological progress. Each new analysis technique reveals additional layers of sophistication in ancient engineering that force us to expand our understanding of what was possible in the distant past and question what knowledge may have been lost over the millennia as we reach the end of our journey through these 7 incredible ancient engineering feats. We're left with more questions than answers, from the impossible precision of the Great Pyramid's construction to the perfect spheres of Costa Rica, from the massive stones of Baalbek to the sophisticated mechanics of the Antikythera device. These achievements consistently challenge everything we thought we knew about ancient technological capabilities. What becomes clear is that our ancestors possessed knowledge and abilities that seem to transcend the supposed limitations of their time. The mathematical precision, engineering sophistication, and manufacturing capabilities evident in these structures suggest that human technological development may not have followed the neat linear progression that conventional history describes. Instead, we may be looking at evidence of advanced knowledge systems that were developed, applied, and then somehow lost to the passage of time. The consistency of this precision across different continents, cultures, and time periods is perhaps the most compelling aspect of these discoveries. Whether we're examining stonework in Peru, underground cities in Turkey, or mechanical devices from ancient Greece, we find the same levels of sophistication that challenge our fundamental assumptions about ancient capabilities. This suggests that advanced engineering knowledge was far more widespread in the ancient world than we've ever imagined. These monuments and artifacts stand as silent testimony to human ingenuity that we're only beginning to understand. Each new analysis reveals additional layers of complexity that force us to expand our conception of what was possible thousands of years ago. The tools, techniques, and knowledge required for these achievements remain largely mysterious, creating a profound gap between what we observe and what we can explain using conventional archaeological frameworks. Perhaps most importantly, these discoveries remind us that human creativity and problem-solving ability have always been extraordinary. Our ancestors faced seemingly impossible challenges and somehow developed solutions that continue to amaze us today. Whether they possessed forgotten technologies, lost scientific knowledge, or simply approached problems in ways we can no longer comprehend, their achievements stand as monuments to human potential that transcends time itself. These 7 engineering marvels represent just the beginning of what may be a much larger story about ancient capabilities that we're only starting to uncover. As new analysis techniques reveal ever more sophisticated details in these ancient works, we may find that the gap between ancient and modern engineering is far smaller than we ever imagined.